Today we are learning about systems of equations. So a system of equations, specifically linear equations, is going to be something that has two or more equations. So a system is going to have two or more equations. So no longer are we just dealing with one equation, we're dealing with two equations. All the ones that we will work with in Algebra 1 will have two equations. So an easy example of a system of equations would be like y equals 3x plus 4 and y equals 2x minus 7. This would be a system because it has two or more equations. So the solution to this system is going to be very simple. It is the point where the lines intersect. Our solution is going to be the point where the lines intersect. So if I had a picture of two lines here just to give you a visual, here's one line, here's the other line, the solution is going to be this point right here. And you need to note that I will do all of my solutions today. I will label all of my solutions in purple. Okay, so my color for solution is going to be the color purple. Now, there is another way we can find a solution, and the other way we can find it is it can also be the values, plural, of x and y, so the values of x and y that make an equation true. It's the values of x and y that make an equation true. And this is actually the first definition that we're going to talk about. We're going to put that to use on problem 1 here. So problem 1 says prove that 2, 5 is a solution for the following system. For the solution x plus y equals 7 and 2x minus 3y equals negative 11. So if I need to find out if this point, 2, 5, is a solution to this system, then I need to figure out if I plug in 2 for both of my x's and I plug in 5 for both of my y's, do these equations equal what they say they will? Does the first one equal 7? Does the second one equal negative 11? So I'm going to start with the first one. So I have the point 2, 5. 2 is my x value and 5 is my y value. So I'm going to plug in, instead of x, I'm going to plug in 2, plus instead of y, I'm going to plug in 5. And I want to find out, does it equal 7? So I do the math on the left side. Well, if I add 2 plus 5, I get 7 equals 7, so it's true. So I'm going to do the same thing for the other equation. So it said 2x minus 3y equals negative 11. So instead of x, I'm going to plug in 2 for x, because that's what it told me the x value was. So I already had a 2, so this 2 is this 2, and x is now 2 because x was 2. Minus 3, and instead of y, I'm going to plug in 5 equals negative 11. So I'm going to do the math on the left side. Well, 2 times 2 is 4. 3 times 5 is 15. So 4 minus 15 equals negative 11. And 4 minus 15 is going to give me negative 11. And negative 11 equals negative 11. So since when I plugged this point in, when I plugged in 2, 5 here, into both equations, I got two things that were true. That tells me that yes, this is a solution. So yes, 2, 5 is the solution. That's the answer I've come up with. So I'm going to do the same thing for number 2. So they give me, it wants to know, is negative 2, 0 a solution for this system? So remember, negative 2 is my x value, 0 is my y value. So instead of y here, I'm going to plug in 0 equals negative 2. Instead of x, I'm going to plug in negative 2 minus 4. Remember that this negative 2 in black was this negative 2 here. The negative 2 in green was my x value. So if I do the math on the left side, on the right side, I'm sorry, I have 0 equals negative 2 times negative 2 is positive 4 minus 4, and 4 minus 4 is 0. So it worked out on the first equation. So I'm going to plug in what I know. Instead of y, I'm going to plug in 0 equals, instead of x, I'm going to plug in negative 2 plus 4. So if I do the math on the left side, that's still 0. Negative 2 plus 4 is positive 2. Well, 0 doesn't equal 2. So this equation right here, 0 equals 2, is not true. So this is not true. So that tells us that the point negative 2, 0 is not a solution. Tells me that negative 2, 0 is not a solution. So most of the times we can actually solve these by graphing, which is so much easier. And so what you need to remember if you're solving by graphing is that the solution is the intersection. The solution is the intersection. So if I have a system of equations with one solution, that means I have a system of equations with one intersection. If it has one solution, it has one intersection. So to give you a visual of this, I'm going to draw two lines that intersect once. So here's one line, and here's my other line. So since these lines intersect one time, there is one solution. There is one solution, and that would be my solution. So if I had a system, looking at the next example, that had no solutions, well, something that has no solutions is going to be something that has no intersection. If it has no solution, it has no intersection. Well, think about it. What kind of lines have no intersection? And the only kind of lines that have no intersection are going to be parallel lines. So a system with no solution is going to be a system like this. The lines are going to be parallel. If they have no solution, they have no intersection, they are parallel lines. My third option for my solutions is that I can have what's called infinitely many solutions. That'd be the same thing as saying infinitely many intersections. Well, if it has infinitely many intersections, what that means mathematically is that it intersects everywhere. That really, this is two lines. Here's one line. And these two lines are actually the same line. They're on top of each other. So this is an example of a system that has infinitely many solutions. The lines are actually the same line. If they have infinitely many solutions, they are the same line. So question 3 down here says use the graph to solve the system of linear equations. So remember our solution, if we're looking to solve the system, we're looking for where these lines intersect. Well, looking at my graph, they intersect here at the ordered pair -1, 4. So we are saying that our solution from the graph is the point -1, 4. Well, I can check that algebraically because I can plug it into my equations and verify just like we did in problems 1 and 2. So remember, I'm going to make -1 as my x value, 4 is my y value. So I had two equations. I had first y equals -x plus 3. So instead of y, I'm going to plug in 4 equals negative, instead of x, I'm going to plug in -1 plus 3. So that's 4 on the left. -1 plus, or sorry, negative -1 plus 3. Well, I have negative, negative. That really becomes a positive 1 plus 3, which is 4. 4 equals 4, so that means it's a solution to the first one because it worked. Now I'm going to do the same thing for my second equation. My second equation was y equals x plus 5, so I'm going to plug in for y, I'm going to plug in 4 equals, for x I'm going to plug in -1 plus 5. So on the left side I still have 4. On the right side, -1 plus 5 also gives me 4. So since both sides were 4, that means it's a solution. So I know both graphically and algebraically that it works, because when I looked at the graph, I found out where it intersected. When I plugged it in, they both gave me 4 on both sides. So for 4 through 7, I'm actually going to graph them by hand on the iPad, but I'm also going to tell you how to graph them in the calculator and how to find the intersection. So when I'm graphing lines by hand, starting with the first one, my y-intercept is -6, so I'm going to begin at -6 on the y-axis. My slope is the number in front of x, which is -1. To make that into a fraction, I'm going to put it over 1. So I need to go down and right, or I need to go up and left. So I'm just graphing lines, which we've already done before. I cannot go down and right from where I am, but I can go up and left. So I'm going to go up 1 and left 1, and up 1 and left 1, and up 1 and left 1. And I'm going to get all of these points on this line here. So this is my first line. Y equals -x minus 6. I'm going to do the same thing with my second line. Well, my y-intercept in this case is going to be plus 0, so I'm going to begin at 0. My my slope is the number in front of x, which is 1. I'm going to make that into a fraction, so it's 1 over 1. They're both positive, so I'm going to go up and right. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Or down and left. It's going to put me back on the same line. So when I connect these two lines, I am looking for where they intersect. That would be their solution. So looking at these two lines, my intersection is this point here. This is the point where the two lines connect to one another. So that is going to be my solution. So my solution is the ordered pair -3, -3. Remember, when I plot points, it's an x and a y value. First, I go left or right, and then I go up or down. When I'm plotting points, I first go left and right, then I go up and down. So my solution to this system is the solution -3, -3. So now I'm going to tell you how to solve these in the calculator. How to solve using your calculator, because the cool thing is your calculator will actually find the intersection for you. So first of all, you need to get your equations. You need to get your equations into y equals form. You need to solve them for y, like we've been doing every Friday. So first thing you do is make sure your equations are in y equals. The second thing you're going to do is you're going to go to y equals in the calculator, and you're going to type them in. You're going to type your equations in to y equals in the calculator. Second thing you're going to do is you're going to type the equations into y equals in the calculator. The third thing you're going to do is you're going to go look at the graph. You're going to go look at the graph, so you're going to hit the graph button. And there's a very, very, very important note here. Very important note. You must be able to see the intersection. When you look at your calculator, you must be able to see the intersection. If you cannot see the intersection, your calculator can't find it. Okay, so you need to graph it and you need to be able to see the intersection. If you can't see the intersection, you'll need to zoom. And the fourth thing you're going to do is you're going to press second, trace, number 5, and then you're going to press enter, enter, enter. If you do all of these things, second, trace, number 5, enter, 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 it is going to give you, your calculator is going to give you your solution. It will give you the intersection. It will give you your intersection, so you don't have to worry about graphing them by hand. Now, I don't have a calculator to show you how to do this. I'm going to help you solve these by hand, and then, or solve them like so that you can graph them in the calculator, and then you're going to graph them in the calculator and figure out what you do. So the first thing I need to do is I need to get y by itself in the second equation, because notice the first equation, if I look at it, y equals 2x plus 2, look, it's good to go. Y equals form. The second equation, not in y equals form, so I need y is on one side, everything else on the other. That means I need to move my plus 2, so it's going to become a minus 2, and then it's gone. I get y equals negative 2x minus 2. So that's my new equation. So what I want you to do is I want you to go to y equals, and in y1, you're going to type in 2x plus 2, and in y2, you're going to type in 2x minus 2, and you're going to go look at your graph. And then I want you to pause the video until you have done that. Alright, so now you should have graphed these in the calculator, and you should go, when you look at the graph, you should see this picture. So remember, we are trying to find the solution. That is what we're looking for here, is the solution, which another word for solution is the intersection. Well, if you look at these lines, you should notice that they are parallel. So if they're parallel, there is no intersection. So there is no solution. There is no solution to this system of equations. So we can't do anything else to it. That is our answer, is no solution. Okay, I'm going to do problem 7 next. I know it's not going in order, but I'm going to do problem 7 next. So notice my second equation here. I already solved for y. This one's ready to go. My first one, I've got to solve for y, so I need to get y by itself. I need y's on one side. I need everything else on the other. So I'm going to move the 2x over. It's going to become a minus 2x, and then it's gone. Then I'm going to get rid of the 3 that's in front, so I'm going to divide everything by 3, and it's a positive 3, so I'm going to divide by 3. And that's gone. So I end up with, for my equation, y equals negative 6 divided by 3 is negative 2 minus 2 over 3x. So those are my two equations. So I want you to go to y equals. I want you to type the first one in y1, and the second one's going to go in y2. So I want you to type this in, and I want you to pause the video until you type those in and go look at the graph. Okay, so you should have graphed these, and when you graph them, you're going to see something like this. These lines look like they might be parallel. I'm telling you they're not. This line is a little bit less steep than the gray line here, I promise. So in order for us to find the intersection, you need to make sure that you go to zoom and out, and then you want to hit enter again so that it will regraph it for you. And then if you don't see the intersection, repeat that process. And eventually you're going to see a graph that looks like this. So these are the same two lines, and I've gone ahead and graphed them. And then when you get them graphed and you are able to see the intersection, to find the intersection, remember, to find the intersection, we want to do second, trace, number 5, and then press enter, enter, enter. So enter 3 times. And your intersection is going to come up with, or should come up with, the ordered pair negative 30, 18. That is our solution to this system. So 30, negative 30, 18 is where these two graphs are going to intersect. Let's look at number 9. Or number 8, I'm sorry. What is the solution to the system of equations below? Well, I'm just looking for where they intersect, and these two particular lines intersect at the ordered pair, negative 1, negative 3. So that would be my solution for this system. I'm going to go back now and do problem 6, but in order to figure out the answer to problem 6, the first thing I need to do is solve both of these for y. So if I'm solving for y, remember I want y's on one side, everything else on the other. So I'm going to get rid of this positive 6x first. It's going to become a negative 6x on the right side. And then I need to get rid of the 6 that's in front of y. So I'm going to divide by 6 and divide by 6, and that's gone. And I end up with the equation y equals negative 3 over 6 is negative 1/2. Negative 6 over 6 is negative 1x. So this is the equation negative 1/2 minus 1x. So I'm going to do the same thing with the second equation. I'm going to solve it for y. So I need y's on one side, everything else on the other. So the negative 6x becomes a positive 6x. So that's gone. And then I'm going to divide by negative 6 because that was the number in front of y. And so that negative 6 is gone. And to get y by its, or to simplify, I end up with y equals 3 divided by negative 6 is negative 1/2. 6 divided by negative 6 is negative 1x. So I want you to look at these two equations. So the first one is negative 1/2 x minus 1. And the second one is negative 1/2 x minus 1. So if I were to graph these, both of them are actually the exact same line. And roughly sketched, they are both going to cross the y-axis at negative 1/2. And their lines are going to look like this. Since both of them are the same line, they're the exact same equation, that means this particular system has infinitely many solutions. This particular system has infinitely many solutions. It has infinitely many solutions. So for 9, it says, what is the solution to the system below? So I need to figure out where these two lines intersect. Well, in order to figure that out, I need to continue my lines. So I'm just going to easily do that by finding my slope. You can also, and it might be easier for you, take something straight and like a ruler and just trace off the line. I can't do that here, so I'm going to find my slope and I'm going to continue that pattern. So the slope here is from this point to this point. I'm going to go down 1 and right 5. So I'm going to repeat that and go down 1 and right 5 and put a point. I'm just going to continue to repeat that. And repeating that, I get this gray line. So I'm going to do the same thing for my other line. I'm going to find my slope, which is I need to go from here to here. So I'm going to go up 1, 2, and to the right 1, 2, 3, 4. So I'm going to continue that, go up 2 and right 1, 2, 3, 4 and put a point. And I'm going to continue doing that. And in doing so, I end up with this pink line. And I'm looking for their solution, so I'm looking for where they intersect. And they intersect at the ordered pair 10, 2. So that would be my solution to this system. And lastly, I need to have a situation here. A roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. In a second purchase at the same prices, the contractor buys 8 bundles of shingles for $256. The following system represents the situation for the price per bundle of shingles and the price per roll of roofing paper. So we're supposed to graph the system. In order to graph the system, I need to solve these both for y. That means I need y's on one side, everything else on the other. So I'm going to do my normal process. It becomes a minus 30x, becomes a minus 4x, and then I'm going to divide by the number in front of y, which is 30. So I end up with y equals, if you reduce 1040 over 30, you're going to end up with 104 over 3 minus 4 over 30x. So that'd be my first equation. My second equation, to get y by itself and everything else on the other, I just need to divide both sides by 8. And 256 divided by 8 is going to be 32. So once we've graphed this, we're going to find the intersections. We're going to have to put this in the calculator. You're going to put this one in y1 and the second equation in y2 and find out where they intersect. And you are going to end up with the ordered pair. 2032 is where these are going to intersect, so that's going to be our solution. If you need help with putting this in the calculator and finding the intersection, please ask.